Assalamu alaikum wa rahmatullah. Good morning or good evening, wherever you are. I'm Dr. Taha Said, Assistant Lecturer of Anesthesia and ICU, Cairo University, and today we are going to have our seventh session and lecture about scavenging system and pollution. We are going to continue our discussing the parts of anesthesia machine or the OT regarding the anesthesia and the physical principle for that. So today we are going to talk about operating room pollution and what the scavenging system are. But before starting that, we should discuss something first. Why we are wearing masks in the OT? This is a very crucial question. Is the main uh, issue to wear the mask is to prevent spread of infection? Maybe correct. But the main issue we are going to discuss today, the pollution, is the main function of the mask, which is prevented by wearing mask. So wearing mask is mandatory for everyone inside the operating theater. Inside the operating room, everyone should wear a mask to decrease inspiration of these gases. We don't know the full effect of these gases, but we know that they are having greenhouse effect and they are causing pollution. So let's discuss now the operating room pollution. If we are going to compare between a car and the anesthesia machine regarding the produced gases, which one of them is producing more greenhouse gases. We know that greenhouse gases like methane, carbon dioxide, nitrous oxide, all of these are the greenhouse gases. So we need to discuss, is it common, is there is a common between a car pollution and anesthesia gas, anesthesia machine pollution? Unfortunately, we will take desflurane as an example. Here we have a desflurane as our example. Desflurane produce after 1 hour usage green gas like carbon dioxide, nitrous, and methane as if you are driving for average 500 kilometer. This first thing. And it remains in atmosphere undegraded for 10 years. And this is so much pollution to our environment. Moreover, the sevoflurane we are using every day is producing green gases like driving from 5 to 10 kilometers each an hour of a surgery. 1 hour of surgery if we are going to use nitrous oxide as if you are driving a car for 106 kilometers. So these gases having a very tough impact on our environment and on the operating room. So we need to be safe and sufficient to be safe and decrease this pollution to our environment. The adverse health events or adverse health effects to these cases may cause nausea, headache, fatigue, and irritability, and this is the cause for why most of the workers inside the operating room may have headache and fatigue all over the day. It can cause sterility, miscarriage, and birth defect, and this also sometimes some countries make a regulation for women anesthetists to know the effect of these gases against them. They have to sign a consent that they are working in with knowing the adverse effects of these gases. They can cause cancers and liver and kidney diseases. So, what is the sources of this pollution inside the OT or inside the operating room? Maybe the leakage in anesthesia case during filling due to crack in the lines, but maybe leakage of anesthesia case. If you are working with spontaneous breathing techniques on the patient and you are using anesthesia gas, if you are not using the TIVA, total intravenous anesthesia, and you are using inhalational gases, this could be a very big source of pollution. Careless filling of vaporizer, especially if you are spilling vaporizers all over, spilling liquid during filling the vaporizer. Improper ventilation of OR, maybe the OR have bad ventilation and bad AC, absence or malfunction of scavenging system, which will be discussed later, and the prolonged exposure to higher concentration as if you as in using it for induction, especially in the pediatric population where we are using sevoflurane, for example, at 7% and 8% during induction. So, how we are going to monitor these gases? There are two ways to monitor these gases, UK and US, and we are using in Egypt the US monitoring, which is done every 3 months. We are using a unit named particle per million, and we should know these numbers as they are very common in MCQ questions. Isoflurane is 2 particle per million. Halocene and sevoflurane and desflurane are 2 particles per million. The only exclusion to this is nitrous oxide, which is 25 particle per million. If you are using nitrous oxide with halogenated anesthesia cases like all previous fluorines, so should be only 0.5 particle per million. This is a very important question in MCQ, these numbers, and we are using the US measurement, not UK measurements. So, what's the strategies to minimize this environmental and health impact? To use TIVA, and almost in most of European countries and US, they are using the total intravenous anesthesia using propofol infusion for sedation and remifentanil for analgesia. And this technique is very good because, as you know, that TIVA, once you stop TIVA, the patient could gain his conscious within 10 to 15 minutes. It's preferable if there is an option to use regional anesthesia or blocks, spinal brachial plexus block, or any other nerve block. It's preferable to use it. Try to minimize leakage by checking the anesthesia machine, air conditioning and well ventilation of the OT, usage of low flow anesthesia, and finally scavenging system, which is our topic. Next slide. Okay, as we remember previously from the circuits that The circuit is coming from flow meter, then the control circuit, and here we have inspiratory valve, expiratory valve, the bag, and in spontaneous we have this ABL valve, which is connecting the device to outside. This connection is connected to the scavenging system, or in the controlled circuit or the controlled mechanism, like in giving the patient muscle relaxant, that the scavenging system is connected after the relief valve. So what is the scavenging system? This is a very good question for oral exam, and this is a good question for written exam. Components of scavenging system: 5 is collecting gas collecting assembly, which is at ABL valve or ventilator relief valve. Then the transfer, which is a short tube. Its beginning is 19 millimeter and its end is 30 millimeter. And then the interface, which we have two types, open and closed. We will discuss the difference between them. And gas disposal assembly tube, which is connecting the interface to a storage or gas disposal assembly, which is having two types, active or passive, and we will discuss them. The transfer means, I said here, the beginning of the hose is around 19 millimeter width, and then it will have an adapter to be connected to scavenging connector at 30 millimeter width. So what's the most important part of this device is the scavenging interface. This part. Okay, why? Because this part is protecting the patient from excessive positive. If we have a kink here, it will protect the patient from this positive back pressure or negative pressure if the vacuum is overworking. And this interface could be open or closed. We have two forms. Here is the open form. Open form is only connected with active scavenging and is used in active scavenging. Okay, open form is connecting the transfer means to the interface through this tube, and the all waste products is coming through the another tube to the vacuum directly. And here is the reservoir. Why? This is a very important question. Why these waste products doesn't go inside this reservoir? Because it's connected to active vacuum, which is active scavenging. Active vacuum, which is sucking these waste products directly to scavenging disposal assembly. Okay? But what happens if this vacuum is overworking? Here we have two openings in this reservoir. It's just to equalize or make the equilibrium to this in this environment to avoid the patient excessive negative pressure applied to the patient. So the equilibrium is done by this opening, which is equalize the atmospheric pressure outside the reservoir to atmospheric pressure inside the reservoir. Here we have a good example like this in the OT. If you are going to use a saline bottle, if when you are using it, it collapses over itself during usage. This because of the negative pressures applied inside it to make the fluid flows to the cannula. But if you make a puncture with a needle to this bottle, what will happen? The bottle will expand again, and if you try to apply any positive pressure from outside, it will equalize and make the fluid coming outside this bottle. This is an example like this open interface with active scavenging system like the bottle of saline inside the operating room. We have discussed the open interface, so let's discuss the closed interface, which is closed over itself. It doesn't interact with atmosphere. So we have two inlets for the waste gas, okay, and then going passively to this disposal assembly. In passive disposal assembly, this disposal assembly is higher than anesthesia machine. So it could be in the roof of the building or in the roof of the hospital to allow passive flow of these gases. It will go up. This gas is going up, doesn't going down. Unlike the active scavenging system, which is the disposal assembly could be at any level of the hospital building. Okay, so enclosed interface and with passive scavenging, the disposal assembly is at a level higher than the operating room, and the inlet of the waste gas is going by the diffusion and the passive flow of these gases. But what happens if we have a kink in this waste gas exhaust hose? It will apply a positive pressure to the patient. No, it will apply a positive pressure here to a relief valve which will open at 5 centimeter water, and it will give a chance to allow the maintenance of this system before starting next patient, because this valve is connected to an alarm, and this alarm will having an oral sound or having a light, so it will allow us to have to see a problem, and after that it will allow us to maintain and repair this error, and it will have less impact of pollution than having these gases inside the OT. If it's a closed interface with active scavenging system, okay, here is the waste inlet again, okay, and here we have a central vacuum, and here we have a vacuum control valve. It will allow the flow of these gases through the vacuum. Okay, what happen if we have a kink here? It will allow positive pressure valve to release these gases. What happen if we have excessive active vacuum? It will allow this negative pressure valve to be relieved and allow equilibrium for the system and avoids vision problem. In this closed interface with active scavenging system, we have also a reservoir. If this vacuum is having a fault or not working well, this reservoir vacuum will store some of these gases, and it will expand, and when it expands it will give alarm that we have a problem. Don't use the device or don't use the system till you repair. Okay, so this is the main function of this bag. Interface is very important, and you should know the difference between the open and the closed interface, and which one can use the active and which one is use the passive scavenging system. Okay, what's the hazards of this system? It will add to complexity of this of anesthesia machine. Much more lines, much more hoses and connection. This will having a much complexity to our system. Excessive vacuum in active scavenging, misconnection of the hoses with each other, and finally, if we have an obstruction which is causing positive pressure, it could cause barotrauma to the patient. And now we have reached to the end of our session. This session is very small, but it's very important because not all the hospitals are using this system, but this system is saving our environment. So it's very important to know it. Thank you.